servos. Quite straightforward relatively compared to stepper motors. On a Genie motorboard we've got 3 plugs here for servos, whereas on the Genie 18 we've just got one output here. Now you might have remembered from previous episodes I talk about this output being unamplified. So whereas on a DC motor you might plug it up to be amplified because they actually draw the power from this bank of transistors. Whereas this one has its own power supply. In this case we've got black, red and yellow, and on the servos you might find in college it's brown, red and orange. So brown is negative, red is positive and orange is the signal. Now the way it works is what's called a pulse width modulation. So the Genie will send out a pulse width, so it's basically a constant pulse, whereas the on time varies depending on what the angle is, and that's called PWM. You don't need to know much more about beyond that. If you're design engineering students, you need to know what a pulse width modulation signal is, to about this level anyway. So we talk about the duty cycle being the time it's on for, and the servo will decipher that. It's got some electronics in it and it will decipher that and use it, determine the angle. Now you might find the angle will vary depending on what kind of servo you use, but generally it's assumed to be about 0 to 180. So if I've got a flowchart here, I've got a servo here, so it's the motor command down here. Normally it's set to DC motor, but here we click servo and then we choose what position it is as well as the output number. So bearing in mind you can run three servos on a Genie motorboard. You could in theory actually run 8 with the Genie chip on its own. So you've got 8 outputs, they could be 8 signals and they'd all have the same plus volts and 0 volts. So you'll choose that by just going and choosing the signal output here, and then you choose the position. Now this number here is actually the width in milliseconds, so it goes from 75 to 225. 75 being furthest anti-clockwise, 150 is the midpoint, so it's vertical almost, and then 225 is furthest clockwise. So if I've got 75, 150, 225 with a weight in between each one, you'll see what I mean. Now they can be hacked, so you can actually send them going round and round, but in their default state you can see this dot here, midpoint, end point and bottom point. You can see it goes 180 degrees in total with that command. Now you might need to work out how to do a little bit of maths if you want to have a manual control of it. As you can see, if you've got some kind of sequence that will kind of deliver something, some kind of robotic sequence, you can just do your position here and then have a wait command or whatever. But if you want to have, say, an analog input, then you'd want to use a potentiometer. So dials and sliders, put potentiometer on that one, and then plug up 2 of these, so the plus volts and the wiper, so you've got an analog input, and then you'd want to assign the, so I'll just leave one of those servo commands, and we'll just have an analog input here, and we'll read the full range of A0. Now bearing in mind that's 0 to 255, I need to scale that from 0 to 255 to 75 to 225. So how do I do that? I will use the scale command rather than using expression, because the trouble with this is it doesn't have decimal scales in it, whereas this you can scale up or scale down, so you can divide if it's less than 1. In this case I'm going to bring the number, instead of 0 to 255 we're going to bring it to 0 to 150, so that's the full range. So that means I'm going to take variable A, in a minute I'll assign that to be variable A, and I'm going to scale it by 255 divided by 150, which is about 0.59. Okay, so that will bring the range of the analog input down. Now I might have confused you first because I need to assign variable A to be that analog input first of all. Okay, so that means A becomes that range of 0 to 225, then it becomes a range of 0 to 150, and then we'll use this one and we'll say A equals A plus 75. So that will bring 0 to 150 to become 75 to 225, which is the range the servo likes. And then I'll just go around in a loop like that. Don't forget, because we're looking at the full analog range here, it's not going to have any no command, but you still need to draw one in. So if it's not in the full range, it'll go around here, but that never happens. Okay, so then when you press play, you should now be able to control it. Okay, so yeah, I forgot to just change that to being position A. That's probably why it doesn't work. So now let's give that a go. So now you can see we get the full position. 100% down to 0.